So we're going to solve this system of equations with a matrix equation. Now you guys know already that you can do 3, 4, -1, 3, 5, 1, put that in your calculator and do RREF and it will give you the answer. Okay, that's one way to do it. There's another way, and that is to use a matrix equation. Hey guys. Okay, so to use a matrix equation, and I will give you this on a quiz or test and say, solve the system with the matrix equation, and you have to write the steps out so that I know that you can do something besides just plug this in your calculator. So you're going to write 3, 4, 3, 5 times xy equals -1, 1. This is called the coefficient matrix. It comes from the coefficients on x and y, 3, 4, 3, 5. This is the variable matrix. It comes from the variables in the equation. And then this is the constant matrix. It comes from the constants. Math is wonderful that way. Names make sense. Okay, so over here I'm going to show you an algebra equation that you're very familiar with. Let's say I have 8x equals 16. If you were to solve this, wouldn't you guys divide by 8 on both sides? Okay? So over here, if we want to get the variables alone, because that's what we're trying to do, we're trying to find what x and y are, it would be nice if we could divide by this matrix. But there is no division with matrices. So instead of dividing by 8, we could think of this as multiplying by 1/8, because 1/8 is the inverse of 8. And if we multiply by that, then we get x equals 2. So multiplying by the inverse has the same result as dividing. So that's what we're going to do over here. We are going to multiply both sides by the inverse of this. So over here, we talked about what happens when we multiply a matrix by its inverse. We get 1, 0, 0, 1. So I'm not going to write all that work out over here because I know that when I take the inverse of this times that, I'm going to get 1, 0, 0, 1. Just like I know when I take 1/8 times 8, I get 1. So then it's going to be times xy. And I've got to multiply both sides by the inverse. Okay? This is the step that you'll need to write out. Now, normally you wouldn't even need to write this 1, 0, 0, 1 out. I'm just doing that to show what happens. If we call this matrix B and I multiply both sides by B inverse, that cancels out and becomes 1, 0, 0, 1. That's what I'm doing there. And 1, 0, 0, 1 times xy is going to just equal xy. Okay? So if I take 1 times x plus 0 times y, I get x. If I move down to my next row, 0 times x plus 1 times y is 1y. So this 1, 0, 0, 1 acts just like a 1 in numbers. Okay, now I'm going to show you how to do this by hand, but then I'm going to show you how to do it on your calculator, because when you go to do this for me on a quiz, you need to write these steps out, but you're going to be able to plug it in your calculator and do the calculations that way. Okay. Now, those of you that just walked in, you missed how to find the inverse of this. So here's what you do. 15 minus 12 is 3. So I start with 1/3. Then we're going to flip these numbers here, 5 and 3, change the signs of those, -4, -3, and then we have to multiply it by -1, 1. So this fraction in this matrix is the inverse of that. Now, I'm not going to deal with my fraction yet. I'm just going to leave 1/3 out there. So xy is equal to 1/3. Now, I'm going to do matrix multiplication. -5 plus -4 is -9. Now, I come down to my bottom row. +3 plus 3 is 6. Now, I'm able to multiply my 1/3 through there and get nice little integers. So that gives me a -3 on top, a 2 on the bottom. And if that is equal to xy, then that means x equals -3 and y equals 2. So my ordered pair that's a solution for this system of equations is negative 3, 2.